Hello, hi, it's me again. So we're looking at example 11. The diagram shows a prism whose cross-sectional area is a right angle triangle. Okay, add the two letters AL over here. Its cross-sectional area is a right angle triangle. So basically they're saying that this is the cross-sectional area. This is a right angled triangle. And as you can see, if I cut the prism this way, right? If I slice it, slice it, slice it, slice it, I keep cutting, I will keep getting this right angled triangle, okay, as my cross-sectional area. So that's what they mean. And they have given some dimensions like AB is 24, BC is 8, and FC is 6 cm. So calculate the length of FB. F is the hypotenuse of this right angle triangle, and since it's right angle, you can just use Pythagoras theorem and easily solve F for FB. Okay, so FB square equals to 8 square plus 6 square. Then you get FB equals to square root of 6 square plus 8 square, which is a nice number. It's 10 cm. Okay, so this is 10 cm over here, FB. Now, remember to write in brackets FB more than 0 because we're only taking the positive square root. So this is just 10. Okay, let's look at part B. Find the area of triangle AFB. AFB is this triangle over here. Okay, let me just erase everything here. AFB is this triangle over here. Okay, now how did they get this triangle? Imagine that they initially had ACB as the triangle. Okay, so this is ACB, right? Let's say there was a triangle flat on the floor. And when it's flat on the floor, you can see that this is 90 degree, right? This angle is 90 degree. And you imagine that triangle was lifted up, and it's standing up right this way. Okay, in a slanted position. Can you see that ABF is still 90 degree, is still a right angle triangle over here? Okay, why? Because this angle here will be 90 degree. It's just like a triangle that's lifted up. Okay, so this is still a right angle triangle, and we already know this is 24 over here. The height is 10 over here. FB is 10, right? So we can just do half times base times height to find the area of triangle AFB. So you get a very nice number, half times 24 times 10, you will get 120 cm square straight away. Okay, you just have to visualize that it's a right angle triangle. Okay, the last question is find angle FAE. FAE is over here. FAE is this one over here. Now, since we know this is also a right angle triangle because this angle is a 90 degree, right? 90 degree floating upwards in the air. Okay, and we know this side is 10, this side is 24. How do we find angle FAE? We just take tangent FAE equals to opposite over adjacent, 24 over 10. Then we find the angle. So let's write it together. For part A, tangent angle FAE equals to opposite over adjacent. Therefore, angle FAE is equals to tangent inverse 24 over 10. And answer to 1 dp, your answer should be 67.4 degrees to 1 dp. And you're done with this question. It's easy once you can visualize. Okay, moving on to example 12. In the diagram, PQRS are 4 markers on a horizontal ground. So that's PQRS flat on the horizontal ground. And QRS is a straight line. So QRS, this is a straight line over here. It's given that angle PSR is 78 degrees, PS is 7.2 meters, PR is 9.5 meters, and QR is 6.4 meters. So QR is over here. Okay. Find angle PRS. PRS is over here. This angle over here. Okay. And for triangle PRS, we already have two sides over here, one angle over here, and we need to find the angle opposite this 7.2, right? So immediately you can be like, oh, just use sine rule. Okay, so part 1, we have enough information to use sine rule. Sine of angle PRS over the opposite side, which is 7.2, is equals to sine 78 degrees over the opposite side, 9.5. Then you will find sine PRS to be 7.2 times sine 78 divided by 9.5. Therefore, PRS is equal to sine inverse of this. Press calculator and you'll straight away get the answer. 7.2 times sine 78 divided by 9.5. Then you take sine inverse, you should get 47.845 degree. Write the 5 SF value first and then the 1 dp, so the answer is 47.8 degree to 1 dp. Now remember that you just used sine rule to find an angle, which means you must consider the other side, the other possibility also, right? So you must say or angle PRS is equal to 180 minus 47.845, just to confirm whether the other side also holds. Then you would get some 132.15 degrees, okay, to 5 SF. But obviously this cannot be possible because one of your angles is already 78. If your angle PRS was 132 plus 78 will exceed 180 degrees. So this one you reject. But you must also write this part. Okay? Okay, so now that we know that there's only one confirmed angle, 47.845, part 2 says find the area of triangle PQR. PQR is this obtuse angle triangle here. You already have the two sides 9.5 and 6.4, but you need the angle in between. So to find the angle in between, let me just write it here. Angle PQR is equal to, oh no, it's not PQR, it's PRQ. Angle PRQ is equal to 180 minus 47 point. Luckily we wrote the 5 SF just now, right? So it's 47.845 degree. Okay, the reason is adjacent angles on a straight line. So you take 180 minus 47.845 and you will get 132.155, which is like what we just did just now, right? So that is actually this angle here, 132.155. And now you want to find the area of triangle PQR, which will be half AB sine C. So it's half times 9.5 times 6.4 times sine 132.155. Okay, you press calculator. So sine of this times 9.5 times 6.4 times half, you will get 22.536 to 5 SF, and the 3 SF value will be 22.5 meter square, since its area 22.5 for the area of the triangle. Okay, for part 3, we're supposed to find the length of PQ. PQ is over here. We already have the two sides over here and the angle in between. So to find PQ, we simply have to use cosine rule. Okay, you go down. Let's form the equation and then we manipulate from there. Length of PQ. Okay, PQ square will be equal to the two sides over here, which is 9.5 square plus 6.4 square. Okay, these two sides, right? 9.5 square plus 6.4 square minus 2 times 9.5 times 6.4 times cosine of the angle in between, which is 132.155. So minus 2 times 9.5 times 6.4 times cosine 132.155. Okay, you press the whole thing into the calculator and then you can take square root. So 9.5 square plus 6.4 square minus 2 times 9.5 times 6.4 times cosine 132.155. Okay, so you'll get some 212.8225 SF. Then to find PQ, you will just take the square root of that. And you must write down PQ more than 0. So take square root of that, answer is 14.58825 SF. But final answer should be to 3 SF, 14.6 meters. Very nice. Okay, moving on to the next one. Find the shortest distance from R to the path PQ. So from R, shortest distance is always the perpendicular distance here. So if you want to find the perpendicular distance here, you need, okay, let's call this perpendicular distance X. Okay, so you just have to write your statement, let the shortest distance be X. Okay, so since you don't know any of these angles, right? You don't know RQP, you don't know RPQ, you don't know all these angles. It is possible to go and find them using sine rule and all that. But let me teach you another way. Okay, if you want to find the shortest distance, right? You already know PQ. Just now you just found PQ, right? You already know PQ is 14.588 meters. Okay. And you also know that triangle PQR's area of this triangle is 22.536, which you found in part 3. If I have my base and I want to find my height, but I already have the area of the triangle, can I use the area of the triangle to find this height? Why not? So let's use that strategy instead of like Tuakaso or other methods. This is another method to find the shortest distance. So what you do is this. You know that the area of triangle PQR is equal to, what did you find just now? 22.536. Okay, this is exactly why we write all the 5 SF values, because we need it for the subsequent parts. Okay, this is your area. And I'm going to write down the statement, let the shortest distance from R to PQ be X meters. Okay, always define. And then you're going to say, you're going to use this area, right? So it's half times base. The base is now PQ 14.588 times the height, which is X, will give you the area 22.536. So form the equation and solve for X. Is as simple as that. So X will be equal to 22.536. You multiply by 2 and then you divide both sides by 14.588. The answer you should get is divided by this. Answer is 3.0896 meters to 5 SF. Okay, I don't really need the meters for the 5 SF. Then after that, I equate it to the 3 SF. 3.09 meters to 3 SF. So my shortest distance is this, 3.09 meters. Okay, and we're done with part 4. Okay, I'll continue with part B in my next video.